Okay, I'm going to try to help you with a couple of these problems that go along with your solids of revolution. Basically, one thing you want to pay attention on these solids of revolution is what your axis is. So in this first one, they have said that the axis is the x-axis. X-axis, remember, is the axis that goes across. So it's basically like the problem they did in the book where they said you take a card to a pole and rotate it around the pole. That's what you're going to do. And I think it's very helpful if you kind of draw the shape. So if I was to spin this around, you can see that you're going to kind of get something going on like this. And you can see this isn't the world's prettiest diagram, but you get a very rough idea that this is going to be some kind of a cylinder shape going on as you spin this around the x-axis. Once you realize it's a cylinder, you now know if you're going to find the volume, you should know the correct volume for a cylinder is the area of the base, since the base is a circle, pi r squared times the height. Now, when you're looking at the radius, you need to be thinking about how far is that cylinder across. Well, that would be this length right here. Let me get a different color. We'll mark these lengths in green. This length right here, the distance going from the center up to the top, is the same as that one there. Either way, you can count on your graph that is 3 units. So you have a radius of 3. And your height would be the distance that is the length, basically how far it is from one end of the cylinder to the other. So the height would be this distance there going through the middle or along the top edge like that. It's the same either way. So that height of your cylinder does make a right angle to the base as it should. Height is 1, 2, 3, 4, 5 units. So a radius of 3, a height of 5. Let's go ahead and plug those in and see what kind of answer we come up with. So it looks like I have a pi times 3 squared times 5. If I'm simplifying that, that is 45 pi in terms of pi. Or you could, of course, type pi in Desmos and get a decimal approximation. But that's how you do that one. We're going to go ahead and skip down and try number 4 as well, if I can make it move there. But that's how you get the first one. Okay. And when we look at number 4 is probably the most difficult one on the page, but we're going to mark the axis again. This time it's the y-axis. The y-axis goes up and down. I remember y gets high. So y goes high, it goes up and down. And then you go there and you're rotating it around, spinning that card around. So let's go ahead and mark what that would be. You would kind of spin the bottom edge around like that. And then the top edge, it's just spinning right around as a point, but it's probably useful to take this point here and look at what it would do. So as it spins around, you can see I have a cylinder shape there. And if I connect that upper ring to the tip, you can see I have a cone sitting on top of a cylinder. So for number 4, I actually have 2 different shapes when I spin that trapezoid. It almost looks like a circus tent, but it's a cone sitting on top of a cylinder. Okay, so the cylinder, its volume would be the area of the base times the height. So that's pi r squared h. Since the cone comes to a point, its volume would be 1/3 the area of the base times the height. And the 1/3 is there because you lose most of the area with it coming to a point. So only 1/3 is left. So very similar formulas. Let's go ahead and see if we can figure out our radius and our height. Radius is the distance across. We'll mark it in green again. It's pretty clear that the distance across that cylinder is 3. And notice even for the cone, it's the same. The base of the cone is the same width, I guess, as the cylinder. So it also has a radius of 3. The height of the cylinder would be the distance between those 2 rings that we've drawn. So that is a height of 3 for my cylinder. And for my cone, it does not have a height of 3. It just goes up an extra 1, 2, I can see. If I look from there to there, I can basically see on that line there, it goes up 2 and over 3. The over 3 was the radius, and the up 2 is the height. So that cone has a height of 2. So I'm going to find the volume of each of these shapes separately. For my cone, it's 1/3. And and I'm going to do it in terms of pi, but we'll put the pi in. 1/3 pi, and then r squared h, and then let's see, that would be 9. 1/3 of 9 is 3, times 2 is 6, so 6 pi. And on this one, we would plug it in, and it would be pi. R is 3, so 3 squared times the height of 3. So that's going to simplify to 27. Get that out of the way. So 27 pi. To get your final answer, you would just need to add the cylinder and the cone together. So it looks like my final answer should be 33 pi. I hope that helps you on, I did the first one and I did what I think is probably the most challenging one. The other two, just kind of draw your solid around like I have and then go ahead and figure out your shape. Hope this helps you and have a great day.